Excellent. I'll start straight away. I have to apologize for the late start and also apologize because nothing I'm talking about today will actually do something like take us to Mars, like NASA, so I apologize for that as well. But I am actually talking about something that is in the limelight quite a lot right now, and that's machine learning. And there's a lot of mystery and a lot of magic that usually surrounds this topic. And what I'm going to take you through is how we use the combination of the graph combined with machine learning techniques to actually take a lot of this mystery out of the situation. This is me at my most formal, combed hair and everything. My name's Tim Ward. I'm an engineer at a company called CluedIn. You can contact me here. I'm always interested in talking about our experiences with the graph and how we've solved certain problems. I've been using, as well as the rest of the CluedIn team, we've been using Neo4j well over 5 years. I personally started on 1.6, and we're currently running a piece of software that has over 180 million nodes in the graph. It's important to know a little bit about what we do before you understand why we made the design decisions in building a decision engine with the graph and machine learning techniques. Essentially, we follow a very kind of similar vision to Neo4j, which is to build the connected enterprise. And a lot of this is because if you take the average company today, they use anywhere from 30 to 50 of these SaaS-based tools to solve things like mail, CRM, project management, code, writing documentation. And as Emil kind of alluded to in his keynotes, that causes what we call data silos. And what we decided to do at CluedIn is take quite a bold and ambitious step in connecting these tools for you automatically. Now, why is machine learning surrounded by such mystery and magic, besides the fact that it's kind of relatively new to the mainstream anyway? Well, like pretty much, I'm sure a lot of people in the room, when we heard about these new engineering techniques that were available, that had this nice buzzword of machine learning, we kind of dove in headfirst and started to learn for ourselves. We started out small with what you would call image object detection, so trying to detect objects that exist within an image. And we used a library called CUDA to do this. And it starts out really promising. Feeding my picture in, it's detected 92% suit, 5% bow tie. It's a bit offensive, but apparently I'm a penguin as well. But you can kind of forgive the machine for detecting that. After all, it's been probably trained on all these different types of data sets. However, what you realize is that you start to fail really quickly. For example, when I decide to pass in our CTO, it very rudely categorized him as 97% a fur coat. You can forgive the engine for thinking that, right? I don't know where it got bucket from, and what I'm trying to say is that this is the magic and the mystery that usually surrounds this topic. And with a little bit more digging, we stumbled across two techniques as kind of regular engineers you could kind of trust. You could see them actually logically working. Clustering's been around for a long time. If you've done anything in the finance space, the banking space, there are clustering algorithms that have been around for a long time. The neural networks is where it really starts to get interesting and where there's a lot more common frameworks out there to make it easier for us as engineers to get started quicker. So after close to 3 years of researching most of these topics, you come out with one realization: that machine learning is good at solving certain problems. It's not the silver bullet that we can use to solve everything. I'll give you an example: the graph. When you ask Neo, give me a node in the graph by an ID, it will always go and do the same thing. Train a machine learning or a neural network with certain types of data and you're suddenly a fur coat when you're not. So we had this simple idea with machine learning kind of under our engineering tool belt now, and that was to build a decision tree that used the best parts of the graph combined with some of the things we learnt within the machine learning field. The first requirement was that we needed a way for this decision tree to persist. And when you think about a tree, well, a graph is just a better version of a tree, so it was a natural fit. The next thing is that we wanted the ability for this decision tree to make multiple decisions and be asking multiple questions asynchronously, so at the same time. This requires a system that's heavy on multiple reads and heavy on multiple writes at the same time. Tick for definitely the later versions of Neo4j. And one of the engineering tactics we always fell back onto was kind of like a nice cushion for us, is that we didn't need this to actually be real time. And I'll give you a practical example. If you asked a Neo4j database what color is the sky, and it said it's red. No, stop, it's green. Sorry, I'm now confident it's blue. You don't want that. You would rather have a system that takes the time, asks more questions, and can come back with a more statistically confident answer, especially if you're trying to automate things, bless you. And we had this ethos that surrounded the whole engineering project, which was, it would be fantastic to get something out of nothing. And the reason for this is that when we're connecting data that exists across potentially 20-year-old systems that maybe the banking industry has or the finance industry has, you don't know how dirty, well, you probably do know, how dirty this data is, how messy it is, and how abused it has been over time. So the reason we had this ethos was because most of the time you at least have something, so we could be really confident with the output from these decision trees. So the reason that we kind of decided to take this somewhat complex design and complex approach was that to connect the enterprise, we, with our customers, saw a common kind of blockage, which was the amount of engineering and development work there is involved in buying frameworks and having an engineering team manually wire these different systems together. That's not just doing it bespoke on yourself, that's even with a framework that you're purchasing. And that's where this kind of bold thing that has consumed our lives the last few years took place. It's worth mentioning before we get too crazy that the kind of methods and the simple approaches that you would be using now as engineers still work really well. There's a lot of pre-processing that we do before we start to make decisions. Like, how many people in the room are engineers? I kind of feel confident I can say these things now. So things like fuzziness of text and stemming and lemmatization and all these things that surround about cleaning up data before you do any processing on it, we still do all of these things. We just combine it with multiple other techniques. It's kind of like a very polyglot design where we use a lot of different systems to do something that they're very good at. We also combine these with common statistical methods today. We use an algorithm called the Pearson's chi-square, which we use to help make us statistically confident if there are relationships between nodes or not. And this is what the algorithm looked like. And just to call absolute bullshit and to pull my point into place, this is not the Pearson's chi algorithm. This is what scares people mostly off these systems. In fact, if you look on the second line there, that's a musical clef. And I divide these both functions by a Batman symbol. This is the, oh, my pixels. I need my pixels back. This is what the Pearson chi-square algorithm looks like. And we use these common techniques to be able to answer and build up these decision engines. So if I'm to get into some demos and actually see this working, if I was to sum up what our end design ended up being, it's this. It's that we built a recursive decision tree that organically grows, expands, collapses, then learns. And when recursion is in place, you know that there are moments where it's expanding, collapsing, expanding, collapsing again, expanding, expanding, collapsing. There's a lot of processing that's going on to make some decisions. The part where the machine learning comes in is where we start to learn. And that's where these neural networks start to really be a really good tool for our tool belt. So let's see it in action. I tried to go with some decisions that are quite relevant to this conference. I hope I didn't spell his name wrong. But just the simple question of who is Emil Ephraim? Well, you kind of already know now from the keynotes a couple of things about him, which country he's born in, and so forth. The tricky part about this is we need to do a bit of pre-processing first. We need to process, is this talking about a company, a location? Is it talking about a person? That's where a lot of this pre-processing comes in. But let's see it in action. Now, what I've done is I have decoupled our kind of large system just down to this decision engine part, and I've booted it up, and I'm going to use, let me see if I can I not show my entire screen? Oh, no, there it is, it's just me. Oh, it's going to be like that, is it? Okay, so what I want to do at the same time is I want to show you my embarrassing Google theme of Adventure Time. And what I want to do is kind of prove this whole getting something out of nothing. I have a Neo4j database over here, and I'm going to clear all data out of this system. So we start with absolutely nothing. And in fact, Emil touched on this in his presentation as well. Context, this idea around context and how important that is. There are two known things in this question. One is Emil Ephraim, and the other is me. I know a lot about me. So what we're going to do is, over here in Postman, I have two kind of records that I'm feeding into this decision tree. And they're pretty simple. I'm just giving my email in there. It's probably a little bit hard to see, but you can kind of trust me there. It's feeding in that I'm a person, I have an email address, and we have Emil down the bottom. So I'm going to post this to the graph. Beautiful. It doesn't take too long. And then I'm going to go over to Neo and just show you, yep, there are our two nodes, nothing magical yet. I've broken down the decision tree into two stages. And it took us a while, but I'm able actually to pause this decision tree at certain times during the process. So if I just process stage one, this can sometimes take a little bit of time, because what it's doing is it's going out and, well, that wasn't too bad. It's going out and it's querying a lot of external data sources to try and figure out, Emil, is there any kind of knowledge that you have on this Emil crazy person? And it'll do the same for Tim. I have a really common name, so that's really hard for me. Emil Ephraim's kind of a little bit easier. There's not too many of him, especially not many that have a lot of social information on the web. And what this tree ends up looking like after the decision tree has been formed is this big bad boy. And it's a little bit hard to see, apologies for that. But essentially what you're seeing here is a huge cluster of possible Tims and a huge cluster somewhere, come on Emil, of Emils. And what it's doing is it's exploding out everything about these different Emils. Maybe one's in healthcare, maybe one's a doctor, maybe one is from jail, maybe that's the one we know. And it's just exploding out these different attributes, and what it's doing is it's trying to find overlaps between this data. And when it finds overlaps, that's when it starts to investigate those paths more than the others. So anything that's so obviously not Emil, like doctor and things like this, start to fold away. They're collapsed and they're never thought about again. All the other parts that are much more juicy, like the fact that we're starting to connect off the fact that we're both male, check. But there's basically there's a lot of attributes. I'm only showing a partial part of the tree. I'm going to just run the second part of this process, which is part of the folding and things like this. This didn't take too long. And just to give you a little bit of the number of decisions it made in folding down all of this data, the graph had to go to a decision depth level of 6, and it had to create 150 nodes for it to come back to a certain point where we can actually start to answer things. So if I go back to Neo, and I'll just run the fold, it's now come back to 2 nodes again. But the interesting part is now when I have to look at Emil, he's now much more strongly typed than it was before. And there is a lot of processing that goes into it. Is it a very expensive operation that's happening? But the thing is that with the transparency of the graph and the structure, it made us much more confident in doing things like debugging and making sure that we are actually doing things the right way. I'm going to skip with time in mind, I'm going to skip the next demo and go to the last one, which is what is the best way for me to contact Emil? I'll go to the last one. How do I sell to Neo Technologies? Now, this is where kind of CluedIn starts to really bring its business value, is that a lot of the time you don't have nothing, you have something. So for this demo, I'm going to actually seed the database with my mail and our CRM data. Our CRM will have lots of contacts, it'll have maybe interactions I've had with the people at Neo4j, and try to build me up some possible paths to talk and potentially sell to Neo Technologies. Beg your pardon? Yeah, sure. So I fed in my email address, and it's figured out I'm an engineer, and it's just figured out my Twitter, and it's figured out a picture of me. You don't want to see it. So let's seed this data. Sorry, I'll just delete all of it first. And I'll go over to my Postman. Beautiful. And I'll just skip to this one as well. So I'm still posting the different attributes like Neo Technologies and me. It makes it a little bit trickier because it's a little bit harder to get to Neo Technologies. Some would say there's some really easy things you can do, like just start playing with the text Neo Technologies and combine them in certain ways and go and look up their website. Yeah, sure, we do that as well, but it leads to a lot of false positives like being a fur coat. So now that that's done, let's have a look at Neo again, and I'm just going to see what the graph looks like now. A big decision tree, much bigger, is built up. It still hasn't completely decided and figured out who I am yet, like the first example, but it started to pull certain people from my mail and CRM data that I know actually work at Neo Technologies and that I have had some interaction with over the last few months. And we can even kind of start to pull out similar things that we are both talking about, like we're both attending Graph Connect 2017. In other parts of the graph, I've talked at a food cafe in Sweden about Neo4j, so it's pretty much every touch point that could help out with me not either contacting or selling to Neo Technologies is kind of usable. We can start to do some path queries to kind of bring back what's the best way. And we do that via, we have this weighted graph where the relationships are all weighted. Okay. Let's go back here. Beautiful. So I think there he is. I think our CTO actually puts it best in the way that one of the secrets I found behind learning a lot about machine learning and getting good results is actually a combination of multiple different technologies, including the graph and including machine learning techniques. And when you got a beard like that, you know he's a good engineer, right? You absolutely know. I can't go anything for shit. So I'll skip this for a second. So the machine learning part, the two really interesting parts, when you talk about machine learning, you usually will split this up into what's called supervised learning and unsupervised learning, where supervised usually will involve some type of human interaction, like correcting a system and letting it learn from that. And we do this in an interesting way. If we were trying to figure out if two Emils were the same person, so two nodes, if we were really not able to find this out, instead of just asking the user something boring like, is this Emil and this Emil the same? If we had a picture of Emil on this node and all of his details on being the CEO of Neo on another node, we can actually, for this node with the picture in it, say, does this guy still the CEO for Neo4j? And in fact, that's the missing piece for us to be able to connect those two Emils. So that's where supervised learning shows itself in the framework. The unsupervised comes in the way that every single decision that was made in all those branches of the decision tree, they all get fed into a neural network. In fact, it's called a recurrent neural network, which are typically better at processing and learning with text in mind. And this job here, the reason why we're kind of really happy with the design and the scalability is that usually this part of machine learning dies when you don't have enough data to feed into the system. It also dies when you say, well, we're not going to have 10,000 people there answering these questions all the time. So if you combine the decision engine and the statistical kind of confidence that comes with that, combined with a neural network, this was the key to us getting good results. I'll skip that. I will say this, because we're all here to kind of learn something, is one of the really challenging parts with this was that with the amount of processing, you can't do that all within the graph. A lot of that is actually done in memory. So what we did is we just replicated the graph model, which is pretty easy, nodes, relationships that have directions, in our application. And this made it very easy to serialize and deserialize this data into memory when we needed to do fast operations and persist it when we didn't have enough data to make or to answer these questions. I will reiterate this because Emil did touch on the fact is that another thing that came out of this whole process was the fact that we pretty quickly realized that connected data, it depends on what you're doing, but it's typically much more interesting to work with than disconnected data. And a lot of machine learning techniques, including the clustering and neural networks are definitely leaning on the graph quite a lot. But typical clustering algorithms are dots on a graph. Connected data is kind of always much more interesting when you're trying to find clusters that are related via some type of attributes. It does give us engineers a lot more power in getting good results. So this is not all about telling how we did it. I think it's a better time than ever to actually say that we're releasing our API that does this today. You can head over to CluedIn.com/API and you request an API key. All you need is a CluedIn account. Sign up for an API key. And why? Because all of the data cleansing that we do in this processing engine, that's part of the API process. Whenever you stick data through us, sounds rude, whenever you stick data through us, you get it out the other end in the structure of a graph, but you also get it in a search index, you also get it in a relational store, and you also get it in a distributed memory cache. So you can kind of think of it as a good way to have kind of like a data service, a data layer as a service, that you can kind of, Emil alluded to it as well, that a graph's good at doing path traversals and joins. It's not necessarily good at doing aggregated-based data like a relational store. And finally, I think the most exciting part is that all the models that get generated out of the decision engine, we expose those to you. So you can use those in other systems, and they can be imported into frameworks like TensorFlow if you're using that, which is one of the kind of more popular mainstream ones right now. For those who are commercial in the room, which was still probably about half of you, I would recommend that you catch us during the lunch. I look like this. Or you can talk to Amelia, and the reason why is that if you work in the financial industry or the banking industry or legal industry in any capacity, there are some pretty scary EU regulations coming up. We're currently helping some of the bigger banks in Denmark right now in solving the right to be forgotten, which is the ability for me to call up a bank and say, I'm moving bank, don't know anything about me anymore. Of course, all the credit history, I can't do that. If you are interested in that, you can head over to CluedIn.com/sales and you can learn a lot more from there. That's me. Thank you.